The neurotransmitter is a chemical. There are many types of neurotransmitters. Neurotransmitters belong to various classes of chemicals. But the chemically gated channels are going to be sensitive to one particular type of chemical. So, for example, some chemically gated channels are only going to be sensitive to dopamine. Others are only going to be sensitive to serotonin. Others are only going to be sensitive to norepinephrine. Once that neurotransmitter binds with the binding site on the chemically gated channel, it's going to cause it to open. Okay, that's what a chemically gated channel is. Do you all understand that? Okay, so there are two types of chemically gated channels on postsynaptic cells. Okay, there are ones that are chemically gated. Those are called ionotropic channels. Ionotropic. An ion is like a very, very small piece of sodium, a very small piece of potassium. One of we've discussed this in class before. The smallest unit of any kind of element is an ion, or a very small unit of an element is an ion. So those are ion. Ion. Yeah, ion. Ionotropic. Tropos is a Greek word for to change. Okay, tropos means change. Ionotropic means that an chemically change induced. So chemically induced change. Ionotropic. It's an ion that induces this change. It's an ion or a chemical which causes this this gate to open, which causes this to open. Okay? Once the ion causes it to open, it's going to do what it has to do. Meaning, once the ion causes it to open, it's going to either allow sodium in, allow potassium out, allow chloride in. So the ion or the chemical or the neurotransmitter in this case is going to bind with the chemically gated channel on the postsynaptic nerve, or the postsynaptic neuron. It's going to cause directly that channel to open, and that's going to cause the effect to happen, which is either, sodium in, the cell becomes more positive. Potassium out, the cell becomes more negative. Chloride in, the cell becomes more negative. Are you all with me? You're there? Cell becomes more negative. Chloride is a negatively charged ion or negatively charged element. We take it with our table salt, the sodium chloride, and sodium chloride is incredibly important. Sodium and chloride are both incredibly important in brain function. It's one of the many reasons we need salt in our diet.
And the second type is?
Oh, I'll get to that.
Oh, okay. Because you said chloride in, the cells become negative.
More negative.
And the sodium in?
Sodium in, the cells become more positive. Potassium out, cells become more negative. So that's ionotropic. Those are also referred to as direct effects.
You said sodium out, cells become more positive.
Sodium in, cells become more positive. Yep. We covered that before, so you might have a note on that, and it's on the slide. Okay, so sodium, yeah. Ionotropic is called a direct effect, meaning that the ion binds with the channel, okay, and the channel opens up, causing whatever is supposed to happen directly, meaning almost immediately or as soon as it binds and it opens, that element starts coming in, the cell becomes more positive or more negative, okay? The other type of effect is called metabotropic, or energy-consuming effect. So this is going to require some energy. It's a long process, but I'll describe what it is basically.